What's up, guys? It's me, Sir Ernest, and today we're going to consider a fluid that is accelerating on a straight line. So let's consider a partially filled container moving on a straight path with a constant acceleration a. If we're going to set our coordinate axis as follows, therefore the acceleration has the following components, ax and az. So therefore, our acceleration will be rewritten as a equals ax I hat plus az k hat, while ay is equal to 0. Therefore, the equation of motion will be equal to partial derivative of p with respect to x equals negative rho ax, derivative of p with respect to y equals 0, and partial derivative of p with respect to z equals negative rho g plus az. This means that the pressure is independent of y and it only depends on x and z. Therefore, the total differential of p is given by derivative of p with respect to x dx plus derivative of p with respect to z dz. If we're going to integrate this becomes the integral of dp from p1 to p2 equals the integral of negative rho ax dx from x1 to x2 plus integral of negative rho g plus az dz from z1 to z2. Here, P1 and P2 are the pressures at x1 z1 and x2 z2. So therefore, we can rewrite this as P2 minus P1 equals negative rho AX times X2 minus X1 minus rho times G plus AZ times Z2 minus Z1. And let's say at the origin, the pressure is P naught. Then at any point xz, the pressure is given by P naught minus rho times Ax times x minus rho times G plus Az times Z. So let's say for these 2 points, point 1 and point 2, the pressure are the same. That is, P1 is equal to P2. And we call these 2 points and any point that satisfy this equation to be isobars. Now the question is, what is the shape of these isobars? So in order to do this, we apply this relationship to our equation of motion. So therefore, we now have P naught minus rho AX x1 minus rho G plus AZ z1 equals P0 minus rho AX x2 minus rho G plus AZ z2, which can be simplified as rho times G plus AZ times Z2 minus Z1 equals negative rho AX times X2 minus X1. So therefore, this gives us this equation. Z2 minus Z1 over X2 minus X1 is equal to negative AX over G plus AZ. Because AX and G and AZ are all constants, therefore this ratio Z2 minus Z1 all over X2 minus X1 is a constant. And what does it mean? Because the change in Z divided by the change in X is a constant, therefore this equation is an equation of a line. In other words, so therefore the line that passes through point 1 and point 2 is a straight line. And any set of points that has the same slope as this ratio negative AX over G plus AZ, those are all isobars. And more importantly, the surface of this liquid will follow the slope. And we call this as our free surface. And finally, we can actually calculate the angle it makes relative to the horizontal, and we just assign it to be theta, given as such. And theta will now be equal to arctangent AX over G plus AZ. And by virtue of the incompressibility of the fluid and the conservation of mass, the volume of the fluid will remain the same before and during acceleration. And during acceleration, the resulting shape will be maintained by the fluid. Also, this means that any amount of fluid rose on one side is the same as the drop on the other side. So that's it. So this is the behavior of a fluid that is accelerating on a straight line. I hope you learned something today. Thank you guys for watching, and I'll see you guys in the next video. Bye bye.